I want to talk more about how we can evaluate infinite limits using the laws of dominance. If this helps you, please like and subscribe for more math help. I have entire playlists on AP Calculus A, B, and BC that I will link at the end of this video. The laws of dominance, which I talked about in another video, but this is essentially looking for the highest powered thing. The highest powered thing dictates our end behavior. We know that from pre-calculus and polynomials, the x cubed, x squared. We know what those look like based on the highest powered thing. And oftentimes, in an example where all of the functions are the same types of things, they're all linear, parabola, whatever, or they're all polynomials, it's very easy to spot the highest powered thing. But sometimes we mix those things up. So for example, the limit as x approaches infinity of 6x plus 4 over e to the x plus 9, the highest powered thing as we go to infinity is e to the x. An exponential function is much more powerful than a linear function. So even though plugging in infinity will result in both the top and bottom going to infinity, the bottom is more powerful and will therefore go to infinity faster. And if the bottom is more powerful, the limit is 0. Now I want to point out, you could do this with L'Hopital's rule. And I'll link another video on kind of writing down L'Hopital. But if the top is going to infinity and the bottom is going to infinity, that is a form we can use L'Hopital for. Think the derivative of the top would be 6, the derivative of the bottom would be e to the x, and then we plug in infinity and we get 1 divided by something getting infinitely large, or 0. Next up, we've got e to the x plus 9 over x to the 93rd plus 7x. I tried to throw you here with a huge exponent. It doesn't matter. The highest powered thing is definitely e to the x. Highest powered thing is on top. The limit does not exist, or it's infinite, however you want to think about that. But this limit, it will grow infinitely large. Again, you could do L'Hopital with this. It'd take a lot. The top would always have a derivative of e to the x, and the bottom would just continue, 93x to the 92nd plus 7. Then 92 times 93x to the 94th. But at some point, it'll end up a constant, and the top will be e to the x. Now, if instead I switched it to negative infinity, this is just something to be aware of. If I plug in negative infinity to this, this becomes e to the negative infinity, which, just as a reminder, a negative exponent means divide. So that means this is 1 over e to the infinity. Well, that's very small. So now, if you think about it that way, especially with this squared in the bottom, the highest powered thing is actually x squared. So in this case, going to negative infinity, highest powered thing is down here. Highest powered thing is in the denominator. The limit is 0. So if we were going to positive infinity, the limit, positive infinity, highest powered thing is here. It would go to infinity. Here, going to negative infinity, the highest powered thing was here because of that negative exponent. So that means the graph must look something like this, where going to one side, it's going towards 0, but going towards the other side, it's going to infinity. Now, similar to problems like this, where we have the same powered thing on top and bottom, we had a 4x squared and a 3x squared, like both of these things would be considered the same power, and we would therefore use their coefficients and just say it was 4/3. We could use that same logic on something like this and say, well, e to the x and e to the x make the biggest thing in both the top and the bottom, and since they're the same power, we could use those coefficients and say the limit is negative 3/4, or 3 over negative 4. So remember, the laws of dominance simply mean locate the highest powered thing, and that dictates our end behavior. And just be careful, infinity or negative infinity, especially with something like e to the x, what that does to the power of that function, or how powerful that function is. Again, I'll link some more examples here.